Hey everyone, welcome to my channel. So today we'll be solving a pretty interesting problem which is reverse nodes in k groups. So here we'll be given a linked list and a value of k, and we are expected to reverse these k groups of nodes individually, and whichever group is unable to be formed using the value of k, we would return them as is. So the result to this problem would look like 3, 2, 1. This is reversing this individual group, and then we would reverse this one 6, 5, and 4, and this final incomplete group would be returned as is. So this is the end result. So let's see how we can do it. And before we deep dive into the solution, I'd urge you to look at the previous video that I uploaded in this series, where I discussed two problems related to reversing a linked list. So the reason I'm asking you guys to look at that video is we'll be using some techniques from those previous videos here, and if you look at it first and then come back here, it would be easier for you guys to understand this problem. But in any case, if you have already seen it, let's dive right in. So first things first, we would use a dummy variable. So this is a dummy node, and we would assign its next value to the head of this linked list. We would also need to keep a pointer to the previous node for each group, and I will call it GP, groups previous node. By group, I mean the group that we would work in the next iteration. So we would work in iteration wise. So for example, in the first iteration, we would reverse this group. In the second iteration, we would reverse this group. And in the final third iteration, we won't be able to reverse it because it doesn't fulfill the criteria of k equals to 3. So we would let it be, right? So for each group, there would be a previous node. For example, in the initial case, the first iteration, dummy node would be the previous node for this group. And when we are done with this group, so when we have already reversed this group in 3, 2, 1 in that order, so that one, the node 1 would be the previous pointer for this particular group, previous node to this group. So we'll see how we can do it programmatically. For now, just know that we have two variables. One is dummy node, and the next pointer of the dummy node is pointing here, and a GP or group previous pointing at the previous node to this group, which is dummy. So there are essentially three steps to solve this problem by like taking this one group at a time. So first step would be to find the kth element of a group, kth node rather of a group, right? The reason being we need to know up to which point we need to reverse it, and after that we can move on to the next group. So to find the kth node, what we would do is we would initialize a counter variable and initialize it with the value of k. In this case, it is 3. We would also initialize a pointer kth to wherever GP is pointing. So this is the initial condition. And now we would have a while loop where we would move the kth variable forward following some conditions. So I'll write the condition momentarily. I'll just write how we are moving k forward. So k would be moved to k next, and then we would decrement count. If you start with 0, then you would obviously increment it, but that's okay. So the criteria to break this while loop would be we need to check if count is not equal to 0, and when it is equal to 0 we would break, and the another condition would be if k is not null, right? If k is not null, then we can proceed with this loop. Otherwise, if k is null, we would break this loop. So both this condition has to be fulfilled for us to continue this while loop, right? So let's try it out before we move on to other steps. First, count variable, we have to initialize it. We already have, for example, here. And then I'll also write kth here. So k is now pointing to GP. So let's start our while loop. These two conditions are being fulfilled because count is equal to 3, which is not equal to 0, and k is not equal to null because k is pointing to dummy. So I'll go inside and I'll move k forward, and I will decrement count. This condition still holds true, so I will move k forward again, decrement count, and this condition again holds true, and I will move k forward, decrement count, and count will become 0. Now this condition has been breached and we will end this while loop. So the state of things are our kth pointer is pointing at 3, which is the kth node in this group, and count is now equal to 0. It doesn't matter, we would really reinitialize it in the next iteration for the next group. So what we have done till now, GP is still at dummy, kth is at 3, right? We have found the kth node for this group. The next step would be, I'll write it here. The second step would be to reverse this group, because we now have access to this node with the help of GP, and we also have the end node. So till this particular node, we need to reverse them. So reverse the group, right? But we need to do some pointer initializations here. So first, we would also have to keep a pointer at the next node of this group. So just like previous, we would do a next node for this group. This is not as permanent as GP. This is kind of a temporary one, but it's good to have. So group's next node would be assigned to the kth next node. So whatever the next node of kth is, that would go into the group next, GN. I'm writing these short forms, so you can expand it, and you would also see in the code that I would provide via GitHub. I have written group next and group previous, but for the sake of this video, I'm just shortening it. Okay, so group next is equal to k's next, and then since we have to reverse it, so we also need at least 2 pointers, which is previous node and current node. So where would the previous node go? The previous node would now be at this particular place. The reason being, if you observe carefully, in the first step, the node that we encounter, it should go to here, because we will be reversing it, right? So it will be 3, 2, 1, then whatever comes here. So I'm not interested in this one. We would do it via the third step, so that we point it into the right node. So for the time being, this node should go to whatever comes at the beginning of this group, right? And whatever is at the beginning of this group is pointed by this node, GN. So previous node would be initialized with GN, and current node would be initialized with the next node of GP. So current node would be GP's next node, right? And now inside while loop, we will have that temporary next pointer, which we already have been using. So the way that we move forward is next would be initialized with currents next. Currents next would be overwritten and repointed to wherever previous is, and previous would be overwritten with current, and current would again be overridden with next. So this is our while loop for reversing a linked list. This is pretty standard, and we have been doing it in our previous video as well. So the condition to break this loop would be, so current should not be null. So current should not be null. If it is null, then break it. Current should not be null. Made a mistake, but that's okay. And what's the other criteria? So current would move forward, right? With each step, it would go forward, and we need to stop it right here. Whenever current is equal to GN, we need to stop it. So if current is not equal to GN, continue the loop. Whenever current is equal to GN, we'll break this loop, right? So let's see. Let's maybe use a different thing this time. So first, we have to initialize next. So next would be here, and we need to get rid of the current next pointer that current pointer has and reassign it to wherever previous is, which is this particular node. And now what we would do is previous should be pointed or placed wherever current is at, and current would be placed at wherever next is at. So I'll erase few lines and write it again. So here we have previous and current next. Okay, these are the state of things. Now in the next iteration, because right now this condition is also not fulfilled, this condition is also not fulfilled, we would go on. So next would be reassigned here, currents next, remember, and currents next pointer would be reassigned to wherever previous is at. Previous would be reassigned to wherever current is at. Current would be reassigned to wherever next is at. Again, I'll just erase few things and rewrite it. Okay, this is previous. Now I think we would have a last iteration of this loop. So next would be reassigned to wherever current's next is at, and current's next pointer would be reassigned to previous. Previous would be reassigned to wherever current is at, which is this one. I'll just write it sideways, and current would go to here. So I'll erase and rewrite and make some space. Okay, so this is my previous pointer, and I'll erase this one as well. Okay, with that done, now you see we have hit this condition. Current is equal to GN, so this would break our while loop. Our reverse is also done. As you can see, 3, 2, 1. The only thing is that we need to re-establish some pointer connections, right? So dummy node should now point to 3 because this would be our new head node or the starting of this group. Whatever the previous node was, it should point to the new head node or new starting node of the group. Head node would be incorrect word. So it should point to the new starting node of the group, right? Earlier one was the starting node, now 3. So in a way, our third and final step would be, I'll just write it here. So these were the 2 steps. The third step would be reassign the GP pointer. I'll just write it this way. Helps to track things. Reassign the GP pointer, and for that I would have to rewrite this entire linked list below. Give me a minute. So we would have 1, 2, 3, 4, 5, 6, 7, null. From 4 till 7, the connections are intact. 1 now points to 4, 3 now points to 2, and 2 now points to 1. And the dummy node, I'll use a different ink, it points to 1 currently. And there is this GP node or group previous, right? Okay. With these things set up, we also have other variables, kth and previous, and gn, next and current, right? So here is our kth and previous, and this is gn, current and next. Although we do not need these 3 variables, I'll just remove them to explain you clearly. We also do not need it, but anyway. So our next step for this particular like this third step would be what we need to do here is okay, we need to keep a temporary variable, right? We need to make sure that we have this connection wherever GP was pointing. So first thing would be put a temporary variable to where GP's next was, assign GP's next. So this next pointer needs to be reassigned to wherever kth pointer is, and then move GP to its next position, which is demarcated as temp. I did not use next because I already have done so for the reversal of the linked list, so I'm not doing it again. So what are we doing here? Okay, so first a temporary variable to GP's next. Here I am putting a or keeping a temporary variable. GP's next, I mean this connection needs to be broken and it should be mapped to kth node. This one should go here, and then GP should be brought to wherever temp is at. So GP would be brought to wherever temp is at. I'll erase these things and it should be clearer. So GP is now at this place. So if you look closely and if you imagine this is the linked list till now. So from dummy we are going to 3, 2, 1 and then the next group. So I think we have achieved what we wanted to do with this group, right? So if I rewrite it, I'll use a different ink for dummy. And then we have 3. From dummy it is to 3, then to 2, then to 1. And 1 now points at 4, which points at 5, 6, 7, and then null. So okay, we also have GP at 1, right? So we already have GP at 1 and we do not need kth and gn because now we would start another iteration of these entire steps. So 1, 2, 3 would be repeated for number of groups that we have in our linked list. So one group is done, second group we'll do it one by one. First step was to move kth variable. We have to assign kth to GP and then we'll move it forward. So let's do it. I'll use a different ink. Kth should be initialized with wherever GP is at, and I'll have a counter since k is equal to 3, so I'll count would also be 3. So I'll move ahead. K goes to this one, the next variable, decrementing count. K moves to the next element, count decrements. K moves to the next element, and since K is not null, that was another condition. If you look up, this was another condition. K should not be null, and till now we haven't encountered that scenario. So K is not null anywhere, and count is decremented to 0. We have encountered the other condition. Count is now equal to 0. So our moving forward algorithm breaks here. So I'll erase these things. This is gone. So our kth pointer is at the end of the second group, right? Now we have to reverse this. For reversing, first step was to put a group next pointer here, assign previous pointer to this group's next pointer, and assign current to GP's next pointer. Okay. Now we would start our while loop. A while loop would continue till current is not null and current is not at GN's position. Okay. So we are in the while loop. First things first, we would have to put a next variable to keep a track of currents next. And then we would break this connection and point currents next to wherever previous is at. Reinitialize previous with current's value and reinitialize current with next's value. I'll erase the unnecessary parts. Okay. Now, with that in place, we have successfully done so for one node. We would have to do it for the other two. So next goes to currents next. Pretty obvious. Currents next is reassigned to wherever previous is at. Previous is moved to current's position. Current is moved to next position. Right. So erasing the unnecessary bits, we have these things. I'll also erase previous and rewrite it a bit. So here is previous. Now we would do it for this node. So next would be move to currents next. The next currents next connection would be broken and reassigned to wherever previous was pointing. Previous is reassigned to current. Current is reassigned to next. And this is how we have done so for the third node as well. And if you see, now current is at the position where Gn is, and we would break our while loop, the loop that reverses the group of nodes, group of k nodes. Okay, we would also not need these three variables and also this one. This is not needed for the further calculation. So the third step and the final step would be to keep track of GP's next using a temporary variable, and then break off this connection, this next connection like so, and put it to wherever k is pointing at and reinitialize GP to temp variable. So if I erase this, GP would be now at this place, right? So we have finally achieved, if I rewrite this entirely, 3, 2, 1, 1 now points to 6, then 5, then 4, and then 7, and 7 points to null. Our GP is at 4, which is this place, and kth, well, we do not need k now. We would reiterate for the next group, which has only one element. So if we go ahead and if we do it for the first, the moving forward algorithm, so what we would do is we would initialize this with kth and count to be equal to 3. We'll move k ahead and decrement count. So k is not null, count is greater than 0, so we'll move ahead k and decrement count. Now here we have encountered the condition where k is pointing to null. So once k is pointing to null, so we would stop our entire iteration. Like we cannot go further because this is where we have got or reached the end of the linked list. So in these three steps, like 1, 2, and 3, right after the first step, we would have another condition where we'd check if kth is equal to null, we would break this entire loop. So this would essentially look something like this. While while we would put a default true, and we would perform step 1, step 2, and step 3, right? And then it would keep on happening, only that there would be if condition. If kth is equal to null, we would break this outer loop, right? So with that in place, we have successfully achieved what we wanted to do. The only thing is we should not return dummy now. We should return, the return value should be dummy.next, right? So now what we would do is, before I wrap things up, let's discuss the time complexity. So I'll just make a box out here. So time complexity would be, so if you see, these three steps are being performed for each group. And how many groups are there? There would be n by k groups, right? If there are 7 nodes and we need to form group of 3 nodes, then there would be 2 groups. So number of groups, right, somewhere here, number of groups would be n by 3, or n by k rather, to make this case generalized. And so in step 1, we are dealing with k nodes and iterating over these k nodes to move a pointer called kth to the end of the group, right? That's what we have been doing in step 1. And in step 2, here, sorry, in step 2, we are reversing those k nodes. So this step would have O of k time complexity, in which we are forwarding or moving the kth node forward 1, 2, 3, 4 up to k. And here we would have O of k again, where we are moving ahead with reversing these nodes 1, 2, 3, and so on and so forth till k. In step 3, if you see, it's just reassignment of few pointers, so it doesn't contribute much. It is of constant time O of 1. So in short, for or one group, we have O of k plus O of k, which is O of 2k, and this should be multiplied with uh, n by k for n by k groups, which would approximately turn out to be O of n, right? Because we do not deal with this constant, right? So time complexity is O of n, and space complexity, if you see, we haven't used anything, any arrays or any dictionaries or anything like that in any auxiliary space. So our space complexity would be O of 1. So constant space complexity and linear time complexity, right? I hope this was clear to all of you guys. So do check out my other videos, and in future I plan to do many such videos. Uh, if you have any feedback for me, do put it into in your comments to this video. I'll also add the link to the GitHub repo where I have provided the solution in C++, JavaScript, and Python. But first, after going through this explanation, try to do it on your own. And if you do not find, or if you are not sure whether you are able to do it, do check out the codes as well. And yeah, I think this is it. If you have learned something new, do hit the like button and subscribe. And I'll see you in the next video. Okay, bye. Happy coding.